let's talk about Conversions Lab 1. So we're going to go to the notes to start with if my computer will quit lagging. There we go. All right, so all the notes files are my handwritten notes. So I'm going to go ahead and apologize for how they look to start with. But let's just start walking through this. Again, this is a re-recording of the other notes video. If you saw the other notes video, the sound was really, really bad because of the short I had in my microphone equipment. Of course, if this is your first time seeing it because it's a late start, then hopefully you're good. So, conversions. Again, the whole reason that we said that we were going to do the Fantasy Football League for this is because it ties into conversions. Points in fantasy football are converted from actual data. So, running backs and receivers, they get 1 point for every 10 yards they accumulate in a game. Quarterbacks get 1 point for every 25 yards they accumulate in the game because they usually get a lot more yards. So they try to balance it out. Now, you can, of course, can adjust that. If a running back gets 6 points, that's still 6 points. That counts as 1-to-1. And so on and so on and so on. So I just thought it'd be something fun to do. So let's say you're trying to convert something into another unit, but you don't know what it would be. Well, if you've got conversion charts handy, you can use the unit fraction to move between units of measurement. Now, speaking of conversion charts, there is a chart on page 78 in the textbook file and a different one in Moodle that has more on it. So let's go look at those and pull those up for a second. So let me close this out here. Get that out of the way. All right. So first right here is the PDF of the conversion chart. When you click on that, it'll pop up here in your downloads icon in Chrome. You can see I've downloaded it several times. So I thought I told it to open. I guess I did not. So let's go open that up. There we are. All right, so this is the Moodle conversion chart. You can download this for yourself, print it out. I know a lot of you like to keep digital copies of things these days. So it's got a lot of stuff in it. The only drawback to it is that it was not manufactured by the textbook company that made the questions for your labs and quizzes. Excuse me, I'm getting over a cold. There we go. So when you use this, your answers are going to be close, but they're not going to be exact. So you'll get something that is really close to an answer choice that's listed. It may not be exact. Doesn't mean that you did anything wrong. Doesn't mean I did anything wrong. I've had those rocks thrown at me before. It just means that, like I said, this was not manufactured by the textbook company. So it'll be a little bit off. You just pick the closest one that you can get to. The metric scale is here in the middle. Above that in the middle, you got American units to metric units. So all the American ones are on the left and all the metric ones are on the right. Below that, it's reversed, metric to American. You've got temperature formulas. You've got medical conversions, time, weight and mass, whole bunch of things that are on here. This actually has more on it than we're going to wind up needing, but it still helps you to have it. Now, it can be a little bit tricky to find things on here, so we're going to go over that next. We also have this table from page 78 out of the textbook that we're going to use because it has some things on there that we need for the questions. Now, since this did come from the textbook, it would line up a little bit better with the textbook questions, but it still doesn't have everything that we need. So that's why you need to make sure that you have both charts handy. There are some questions where you have to use both charts because you have to jump between units. So unit fraction examples. So let's look at these two questions here. All right, I'm going to start you out with an easy one. 7 pounds equals how many ounces? So I'm going to throw this on the board over here. Hopefully my picture-in-picture is large enough to see. All right, so again, unit fraction. You may have also heard it called the unit conversion. That's the table that we make to set all this up. So if the question says 7.8 pounds into however many ounces, then what you do, let me get my head out of the way. So you start with what you got, 7.8 pounds, okay? Now, let's assume, or pretend for a minute, that you didn't know how many ounces were in a pound. If you go to the conversion chart over here, on the left where it has weight and mass, you'll find it right there. 1 pound is 16 ounces. So we're going to copy that down. But where do we put each one? Well, the unit fraction tells you where everything goes, because you've got to be able to cancel out of the unit that you started in and wind up in the one that you're looking for. So that means that I'm going to put 1 pound there and 16 ounces there, just like I did in the notes page. Now, this falls back on the multiplying fractions rule, okay? So when you multiply fractions, you go straight across the top, straight across the bottom. So that's going to make the top say 7 times 16, and the bottom's just going to have a 1. Now you don't need to bring that 1 over if you don't want to. It doesn't do anything. I usually don't bring any of the 1s over because they're just a waste of time. So, 7.8, sorry, not 7. Lost track of what I was doing. So 7.8 times 16 is going to give you 124.8 ounces. All right. Apologies for my error there. Nobody's perfect. All right. So 7.8 times 16 to give you 124.8 ounces. That is an 8. The glare is making it look bad, and my marker is going out too. There we go. Okay. Now, for this next one, we're going to do something a little bit different. Let's say that you're presented with this option of 21 feet into meters. Okay. So I want to put that one here so we can see it. Yeah, right there. All right. So B. All right. So 21 feet into meters. Okay. So let's say that you're looking at the conversion chart and you're at, all right, feet to meters, feet to meters, feet to meters. All right, I see this in here. So let's use that one. Well, you probably can't see that with the picture in picture. So let's do this here. There we go. How's that? Yeah, all right. There we go. So let's say you found this one under the American to metric units. 1 foot is 0.305 meters. So we're going to come over here. We're going to recopy the 21 feet. And I'm going to put feet in the bottom, meters in the top, because again, you got to be able to cancel out a feet. We found the 1 foot is 0.305 meters conversion. So we're going to cancel that out. And we're going to, when we clean it up, we're going to have 21 times 0.305, which is going to get us, and yes, I'm going to cheat and look at what I've already written out, 6.405. All right, 6.405 meters for that one. Let's say, however, that you did not find 1 foot was 0.305 meters. Maybe you found this one. 1 meter is 3.281 feet. Does not mean you did anything wrong. It just means your answer is going to be a little different. All right, so over here, I'm going to show you how it worked out if you didn't have that. All right, let's see, where's the bottom at? Right there. Okay, so we've got 21 feet. Again, you always want to start with what they gave you. We're still going to have feet in the bottom, and we're still going to have meters in the top. Okay? But now, instead of 1 foot, we're going to have 3.281 feet and 1 meter. How does this change things? Well, you're still canceling out of the feet, but now, instead of multiplying 21 by 0.305, you're going to be dividing 21 by 3.281. When you do that, and again, I'm going to use my notes, you're going to get 6.4005. So a very negligible difference. Now the questions in the lab might tell you where to round to, and they may not. All right. Point is, when you do these, there is a chance that neither one of those, excuse me, is going to be listed as an answer choice. It might just say something like this. It may just say 6.4. So if it does, then you're good. All right, they're the same thing. Don't get bent out of shape if the choice that you have available to you doesn't match what you got in your work. It's going to happen, especially if you use this Moodle chart. All right, so just keep that in mind. And again, I cannot stress enough, using the Moodle chart will skew the answers, so pick the closest one. Okay, let me go back up to big screen here. All right. And I even got it, I've got it in two places. Okay, I've got it here and I've got it there. Okay, so hopefully I don't get anybody sending me messages that says, I didn't get what you got. Well, yeah, you probably didn't, because I told you that was going to happen. All right, so just keep that in mind. Again, I forgot that a nautical mile is not a knot. A knot is a nautical mile per hour, so just don't worry about that. You do have a question about that, but we'll correct it when we look at the student copy. Okay, the barrel questions. All right. The reason why these are getting special attention is because if you look on page 271, down at the bottom, and I don't know why it's not letting me zoom it in, but whatever. There are two different size barrels down here on the bottom left. Barrel of petroleum is 42 gallons. Barrel of any other liquid is only 31. Could be water, could be soup, you never know. But all they want you to know is that the oil barrels are bigger. When you are working these out, you've got to remember that first and foremost, that there are two different barrel sizes. But also, the question in the quiz may not have you just taken it to gallons. It might have you taken it to a different unit. So please keep that in mind. All right. Dual unit conversions, or what we also call a unit rate conversion. We're going to throw those up on the board. All right. Getting the board ready for those that are patiently waiting. All right. So dual unit conversion. There we are. Okay. So let's do this. Let's go back to picture in picture. Okay. So, all right. So a dual unit conversion is also something we can refer to as a unit rate conversion. Okay. And that'll help introduce us to unit rates. We'll talk more about that in a minute, because there are some questions about that on the quizzes as well. All right, so a unit rate conversion, the way that it works, let me zoom this in a little bit for the picture in picture there. There we go, right about there. All right, good. Is when you have a top and bottom unit that you have to take care of. Okay, so here's the first example that we're going to look at. Let's say we got A here is 98 kilometers per hour, and we want to turn that into fix that real quick. We want to turn that into miles per hour. Okay. A couple of things. A trick to this is, before you do these, always check to see if you have any units that are the same. All right. So kilometers and miles are definitely not the same. So that's kilometers, that's miles. So those are different, but they are both over hours, right? So that means that we're not going to mess with the hours. We're going to leave that alone. So our first table, instead of just having one unit in the top and nothing underneath it, is going to say 98 kilometers over 1 hour, because that's what the unit rate is. That's what a speed is. 98 kilometers per hour means that you're traveling 98 kilometers every 1 hour. So that's why that's written that way. And because we like to write rates as fractions, it helps us. So when we go to get out of this, we know that the hours, since they're the same, we're not going to mess with that. So we're going to leave that where it is. We're going to leave it alone. But I don't know what the kilometer to mile conversion is off the top of my head. I know I've got it written there, but let's assume that I didn't. Let's go look for it. All right. So my tendency, even though I know that kilometers goes in the bottom and miles goes in the top, my tendency is to think, all right, I want as many ones in the bottom as possible. That way I minimize how much dividing I have to do. So I'm going to go with this one here. 1 kilometer is 0.621 miles. All right, so 1 kilometer, 0.621 miles. I'm out of kilometers. I've got my miles. Now I'm just looking at 98 times 0.621, and that will get me to, if I can get back to my notes, 60.86 miles per hour. All right, now I'm not going to do the other version of if you used, say, 1 mile is 1.609 kilometers. If you don't do it, you can't. Ain't gonna matter. Again, just to hammer the point home, just because I got 60.86 miles per hour doesn't mean that that's what it's going to say. They may round it up. I don't know where they're going to round it to. They may round it up to 61. That would be what I would guess. But still, when you work this out, you may get something that's not listed. Don't panic. It doesn't mean something's wrong with the question. These questions do mess up from time to time, yes, but more along the terms of, pictures not loading and things of that sort. If that happens, then if you pull up a question that says it's supposed to have an image with it, more often than not, that image either has the question in it or it's got something you need to answer the question. Let me know immediately then, because I've got to fix it. Every time Moodle updates, it likes to mess with those. Whew. Okay, so let's look at one where we don't have any units that are the same. Here, we got miles per hour and the feet per second. Miles and feet are definitely different. And hours and seconds are definitely different as well. So we're going to have to adjust both of them. So here's how we'll set that up. So I'm going to come over here. Okay, so B. Do you see that? Yeah. All right, so we've got 60 miles per hour into however many feet per second. All right. So when we start this, we're going to have 60 miles over 1 hour, because that's what miles per hour means, 60 miles every 1 hour. Right now, some folks might be stuck with which one of those to deal with first. The rule of thumb is you always want to take care of the top unit first, okay? So keep that in mind with this, all right? So top unit, then bottom unit, okay? All right, so I'm going to turn miles into feet. I know that one. Most people know that one if they manage to get out of elementary school. So 1 mile is 5,280 feet. Okay, so now I'm out of miles. I found my feet. And with something I forgot to mention with the first conversion that we did, whenever you get to the unit that you're looking for in the top, you stop. Notice how I didn't go past miles there. I got to feet, So I'm going to stop with that one. But this is a unit rate conversion with 2 units that don't have anything identical. So we've got to come back now and get this hours. All right. What I'm going to do to kind of gimmick this a little bit is I'm just going to recopy it. That way I can do that. And I'm just going to leave it as a 1 because that's not going to hurt anything. And because I want to keep the hours or the time unit in the bottom. So 1 hour I know is going to make 60 minutes. And I know 1 minute is going to make 60 seconds. Okay? I'm out of minutes. I got my seconds. I got my feet per second. So now I'm all set. Whenever I bring this stuff over, I'm not going to bring any of the ones. They're just placeholders. You can bring them if you want to. I'm not going to. So we've got 60 times 5,280 over 60 times 60. Now, if you remember anything about reducing fractions or factoring fractions or any of that stuff, you know that when you've got it factored or, maybe you did prime factors or whichever, basically you're looking for things in the top and bottom that are the same. That's the whole reason we can cross out miles, cross out hours, cross out minutes. We've got the same thing in the top and the bottom so we can get rid of it. I'm going to do the same thing here. I've got a 60 in the top and a 60 in the bottom that I can get rid of. And that will get me to the 5,280 divided by 60, which is going to be 88 feet per second. Forgot how to write there for a minute. 88 feet per second. Okay? So, again, take care of the top unit, take care of the bottom unit, then reduce it best way you can. Yeah, you can see that on the video. It ain't pretty, but it'll work. Okay. Yeah, so you do have some dual unit conversions or unit rate conversion, whatever you want to call it, to deal with when you see these. All right? Let's push on. Fahrenheit to Celsius. So we'll come back to this in a minute. This is just kind of letting you know that we do have formulas that you can use to convert Fahrenheit to Celsius. There might also be some in the book that are a little bit different. I guess it just depends on where you look. Oh, sorry. Let me do. There we go. Now that's a little bit easier to read. Okay. So before we get too far into Fahrenheit and Celsius, one thing I wanted to come back and touch on is what a unit rate actually was. So a unit rate is when you have a rate that has been divided top by bottom so that you've got a denominator of 1. For instance, if we go back to the answer we got a second ago, the 88 feet per second. This was 5,280 divided by 60 to get 88 over 1. We're just not going to show that one. All right, so that's what a unit rate is. The top, it's a rate where the top has been divided by the bottom. More importantly, one thing that we're going to be looking at is something called unit price. Okay? A unit price is figured up by taking whatever the price listed is and dividing it by the quantity. Sorry for the handwriting. So it's price. A unit price is price divided by quantity. For instance, let's say you had a question that said you bought an 8-ounce bottle of something for $2.16. What's the unit price? Well, again, the price goes in the top, the quantity goes in the bottom, so that is going to make 27 cents per ounce. If you were to make this 8 divided by 216, that is a no-no, okay? We have a habit of dividing things in the order that they're given to us because division relies on order. But remember, unit price, you set it up as the price divided by the quantity, okay? Now, sometimes it'll be price per ounce. Sometimes it might be price per bottle. So just kind of keep that in mind as well. We'll look at some examples of that here shortly when we get done going through the notes. Okay, something to keep an eye out for. You do have some temperature things involving Kelvin, all right? So before we get too far into that, let me show you where the temperature formulas for Fahrenheit and Celsius are. Okay? So here are your temperature formulas. The one on the left that says C equals, this means that Celsius, ooh, you can't see that at all. This means that Celsius is missing. All right? Or another way you could look at it as Fahrenheit is, ooh, that's a Q. Fahrenheit is given. All right? So with that formula, Celsius is missing, Fahrenheit is given. This one over here is the opposite. All right? So Fahrenheit is missing, and forget it. And Celsius is given on that one. Now, technically speaking, if you were to accidentally use the wrong formula, you could be able to work your way around it because these two formulas are reciprocals of each other. So Celsius is F minus 32 divided by 18. Fahrenheit is 1.8 times, not 18, good God. F minus 32 divided by 1.8. I'll learn to read one of these days. And then Fahrenheit is 1.8 times C plus 32. So inverse operations. Whatever's being done, do the opposite to solve it. What I mean is this. Let's say that, I'll put this on the board. So let's say that you use the wrong formula. Let's say someone said it's 30 degrees Celsius in Australia in January. What is that in Fahrenheit? So we'll call this an example. So 30 degrees Celsius in, or let's say New Zealand in January. What is that in Fahrenheit? Okay, so we're looking at 30 degrees Celsius into degrees Fahrenheit. This is not one of those conversion chart deals. There might be something that you can use for that might shorten this up, but let's stick with formulas because eventually when we get to the percent section, we need experience using formulas anyway. So Celsius is given. So that means I'm going to use F equals 1.8 C plus 32. All right. So 1.8 goes in place, or no, 30 goes in place of C. Sorry, I lost my train of thought. So 1.8 times 30 plus 32. All right, then I'm going to use my trusty calculator that you're supposed to have. And you've got 1.8 times 30 is 54 plus 32. And that's going to give you 86 degrees Fahrenheit. So in New Zealand, 30 degrees Celsius in January is 86 degrees Fahrenheit. That's because their seasons are reversed. All right. Speaking of reversed, let's say that you used the wrong formula. Let's say that you saw that 30C was sitting there. You're like, 30C Celsius. I need to start with C equals. First of all, no, that's wrong. But it's not the end of the world. So let's say that you went through this whole thing using the wrong formula. You would have C equals F minus 32 divided by 1.8. Again, inverse operations. Multiplying by 1.8 there, dividing by it here, adding 32 there, subtracting it here. It will still work out. You're just going to have a little bit more work on this right side here. And let me make sure that that's actually showing up on the video. Yeah, all right, we're good. Okay, so you are given 30 degrees Celsius. So 30 equals F minus 32 divided by 1.8. You're still going to wind up multiplying by 1.8 because of inverse operations. 1.8 is being divided here. You're going to multiply it there. So 30 times 1.8 on the left equals F minus 32. All right. So 30 times 1.8, we know that that's 54. 54 equals F minus 32. You're going to have to add 32 to both sides. That cancels. This gives us 86 equals Fahrenheit. Same thing, But look how much longer it took you because you used the wrong formula. Okay? So you still were able to get out of it, but look how much more work it took. All right, so just keep that, excuse me, keep that in mind. All right? Whatever they give you, you have to use the other one. Since they gave us Celsius, we have to use F equals if we want to save some time. All right. Now, Kelvin is a different thing altogether. The Kelvin formulas, Kelvin is a temperature that's used in science, mostly, I think like physics and chemistry and things of that nature. I've got some information about it there if you ever want to, whatever. So here are the Celsius to Kelvin and Fahrenheit to Kelvin and back and forth formulas. So make sure that you know where to find those. I would advise putting those in your notes. That way you can flip to your notes as instead of, having to comb through mine. All right. Lastly, converting money, exchange rates. So exchange rates are conversion factors for changing currency. These factors change on a regular basis. So for our purposes, we're just going to use the old ones, or we might even use hypotheticals. But there is a table on page 85 for this that we can find. So the table for this is actually in the pictures that I've uploaded. Here it says when to use each currency conversion. So I'm going to blow this up. All right. So this is a table off of page 85 of the textbook file. So it's broken up into two categories, and it's based off of exchange rates from February 2013. So these are old. These are very outdated. They update all the time. Unless you work in that industry, they're almost impossible to keep up with. So this table breaks it up into two columns, dollars per foreign and foreign per dollar. So that's kind of hard to figure out when you're going to need each one of those. Well, I tried to put it in plain English as much as I could. Dollars per foreign means that's when dollars are needed. And then, let me make this a little bit bigger because it's kind of hard to see. Whoa! All right. Come on. Easy. Well, I guess not. I don't know what's going on with this thing. Well, it'll be all right. So yeah, dollars per foreign is when dollars are needed. Foreign per dollar is when dollars are given. These are multiplication factors, okay? So let's say, oops, I didn't mean to do that. So let's say that you have 50 British pounds, all right? So 50, we'll say 50 British pounds. I don't know what the symbol for that is, and even if I did, I couldn't draw it. And you need dollars, okay? So you're going to take that 50, you're going to multiply it by 1.624, and then that will tell you how many dollars that you're going to get, okay? So 50 times 1.624 gets us $81.20. All right. Now, let's go the other way. Let's say that we were given $81.20 and we needed the British pounds. All right. Stupid thing. All right, whatever. So then that means we would take that 81.20 in dollars, and we're going to multiply that by 0.6158. All right, so 81.2 times 0.6158. That's going to give us 50 British pounds, or 50.00296 British pounds. All right, so there you go. Now, somebody had asked about a problem on the lab where they said, how do I know how far to round it? Because some of them take them to tens, some of them take them to hundreds, some to thousands, and so on. And that's a valid question. You just kind of want to go by what's given to you within the question. Look at how many digits are in the numbers given in the question. And just, if it doesn't say exactly where to round it to, just make a judgment call. The questions on the quiz are multiple choice, so you'll be okay. You can work your way around it. All right, so one more thing. The currency questions are not on the Conversion Lab 1 for the simple reason that I forgot to put them on there. They are on the test and they are on Conversion Lab 2. But the ones on Conversion Lab 2 have their own given conversion rate. So for Conversion Lab 2, you would not be using this table, but you may for the conversion test. I just don't remember if the ones on the conversion test have a different chart or if it's the same chart or what. So in the question, if the question gives you a chart, use that. All right. Okay. So speaking of the assignment, let's pull up the student copy. All right. Excuse me. All right, student copy. It'll download. Sometimes it'll download, sometimes it'll open. Honestly, I don't know which it's going to do. Okay, so reminders. These are the questions you will see on the lab. So these are lab questions, but on the lab, they're scrambled. We'll say scrambled on Moodle quiz. All right, lab quiz, tomato, tomato. Same thing. All right, now, again, this to just keep you from, filling out this paper and handing it to somebody else and say, here you go, that'll be $5. You don't want to do that. All right, so point I'm trying to make is this. On the paper, question number 1 says a baby weighs 7.8 pounds. How many ounces is that? And it's got the choices there. When you open up the Moodle quiz, it might say the baby weighs 7.8 pounds. It might say turn negative 70 Celsius into Kelvin because it's going to be scrambled up. Let's play devil's advocate. Maybe you lucked out and the first question did say the baby weighs 7.8 pounds. How many ounces is that? A is not going to be 93.6. B is not going to be 124.8 and so on. All right. You can't just go through this paper and say 1C, 2A, and so on, because it's not going to work when you open it in Moodle. You will shoot yourself in the foot that way. So please don't do that. Focus more on what the actual answer says. Okay. If you got 0.49 ounces for number 1, then that's the one you want to pick on the question, not just because it says C. You want to be looking for 0.49 ounces. All right. So 1 through 5 is, I believe, American to American units. You're staying within the American system. Number 3, boat is moving at 41 miles per hour. What is its speed in knots or nautical miles per hour? So this is the one that I did incorrectly in the notes, but I'm going to show you how to do it correctly now. All right, nautical miles per hour. You're going to go over to table 2.1 that I showed you earlier. You're going to look right up here. Okay, something that we did on the unit rate conversion a minute ago that I forgot to mention. When we converted the hours to minutes, we used something called a bridge unit. All right. Now, a bridge unit is a unit that you use to get in between two other units. For instance, I don't always know off the top of my head how many seconds are in an hour. So I know how many minutes are in an hour, and I would use that to get in between the two of them. Same thing here. If you're trying to get from nautical miles into land miles, you wouldn't use yards, you wouldn't use kilometers, but you would use feet. Because on this table 2.1, you have the feet conversion for both of those. So you can use that as a bridge to go from one to the other. You can use that as a bridge to go from miles to nautical miles. Okay? So keep that in mind. All right, where is the paper? Conversions lab, there it is. Okay. 4 and 5, how many gallons are in 76 barrels of petroleum? How many quarts are in 58 barrels of water? Remember, barrels of petroleum, barrels of water, different sizes, and make sure that you convert it to the right unit. 6 through 11 are American to metric conversions. Number 9, be careful on number 9. You've got to use both tables on number 9. All right, number 9 says convert 14 cubic inches into milliliters, okay? If you look at the conversion chart from Moodle, cubic inches is nowhere on here. It's not on here at all, okay? So then you've got to hop over to table 2.1. Lo and behold, cubic inches is on table 2.1 as a conversion into cubic centimeters. Does the other conversion chart have cubic centimeters? Yes, it does. Okay, so you can use that to figure out what you're trying to get to, because the question even said cubic inches into milliliters, and this one has a cubic centimeters into milliliters anyway. So cubic inches to cubic centimeters to milliliters. Everybody happy? All right, now let's go to this one over here. So you got your temperature conversions. So make sure you use the formulas. 18, 19, and 20. These are the ones that people cuss about the most on this lab. Let me do my best to try to put your complaints to ease. All right. 18 and 19, both of those, you can tell from looking at the question, you're going to set it up as price per ounce. All right. 8-ounce bottle for $2.16, 6-ounce bottle for $1.50, 19, 24-ounce for $2.88, 20-ounce for $2.20. Remember, unit price, crap, gotta quit using yellow. Unit price is always the price over the quantity. All right. Now, remember that for 18, 19, and 20. The pickle of this is number 20. You can still do price per ounce on number 20. The problem with that is that you can't just do 250 divided by 10, 529 divided by 14. You've got to multiply the number of ounces by the number of bottles if you're going to take it all the way down to ounces, okay? So that would be 250 divided by 50, and I don't remember what 7 times 14 is, but anyway, you're going to get some big decimals that way. You might even get some that are really, really similar, like the 21 feet to meters we did a while ago, where one was 6.405 and one was 6.4005. They might not be a discernible difference, okay? Doesn't mean you can't do the ounces. It just means it's going to be a little bit tougher than if you go the other route, which is to do the price per bottle, okay? It will work out the same way, and it'll be a lot less of a headache for you, okay? When you're comparing decimals, even though sometimes it's in money, and money is always in the hundreds place, sometimes you have to stretch it out a little bit further than that to find the difference. It just happens. I mean, if you notice, 18, 19, and 20, none of them said round it here. So you make your own judgment call there. All right. Okay. Whew, Lordy. I've re-recorded 2 videos today, and I am wore out. So hopefully the sound is better on this one. I did record these with an empty classroom. That's why it's a little bit echoey in here. But now, nobody's having to turn their sound dials up to 11 to be able to hear this. On August 31st, everybody, all my sections that are late start and regular start, all of them will be able to see Conversions Lab 2. It's just that with the late starts, you guys will need to complete Conversions Lab 1 before you do Conversions Lab 2 so that it'll be a little bit easier on you. But after that, the late start should be on the 1 lesson a week plan until everybody gets to the Finance 1 and Finance 2. The reason why we doubled up on Finance 1 and Finance 2 is because fall break is the next week, and I don't want to have to worry with giving a whole bunch of people zeros because they didn't do anything during fall break. One thing to remember, though, is those are due the day that fall break technically starts. I'm just also canceling class on 10/12 as well, because if people have a vacation planned that week, chances are that they're going to be gone on Monday too. The next time that we double up is with linear functions and linear and nonlinear, because those are kind of short and they're easy to put together. And I want to get the whole linear thing taken care of before Thanksgiving. That way, when we come back from Thanksgiving, we're only going to have about 2 weeks left. And we're only going to have 1 week left, because we're going to be doing final review that week. And then finals will open on the 7th of December, and there are no in-person classes that week. So pay attention to where it says things in bold. Those are usually holidays or a day that I've canceled class, or both, like Veterans Day. All right. I've got Labor Day on here somewhere. Yeah, Labor Day too. So just keep that in mind. Okay. You're going to want to refer to this weekly assignment schedule every week. All right. That's why it says weekly, so that you know what's going on. So again, this is the 16-week one. Late start guys, as you saw at the beginning, these two, Conversions 1 and Conversions 2, will be crammed together. But after that, you should be on the pace of the 16-week folks too. And this is to mainly help me get everything graded at the same time, and so that I know what assignment is going on every week. For the fast track folks, they're online. They've got their own speed. So there you go. And, I do have an online late start too, but, all right. All right, that's it. Hopefully the video or the sound on these is good now.